6, 7, 8, 9, 10. Okay, here's the first video for part 1 of 5-7. We're talking about exponential and logarithmic equations. The essential question is, how do the properties and exponents of the logs help you solve equations? And you're going to see there's going to be these properties of equalities and also the power property from logarithms that allow us to do that. So first off, what is the power property or the property of equality for exponential equations? Basically, it says if you have two powers of the same base, then the exponents are equal. Like, look at this little equation over here. If I have 2 to the x power, and that's equal to 2 to the third power, because the bases are the same, the bases are the 2, that means the exponents must be equal, so x must equal 3. So all I have to do in this case, once the bases are the same, I just take whatever's left from the exponents, boom, look, x equals 3. Let's do the same thing over here. 3 and 3, the bases are equal, so take the exponents and set them equal. 2x equals 4, and then we can divide by both sides, and look there, x equals 2. Let's do that again with a little bit more difficult of equation. In this case, the bases are not the same, so what do we have to do? Well, you have to use some number sense. If the bases can be rewritten as the same base, I know 8 is 2 to the third power. So instead of this 8, I'm going to say this is 2 to the third power, and then rewrite that x minus 1 over there. So let's rewrite with the common base, just bring that part down. Now we have to use the power property, and I put simplify in quotes here because you're going to have to use different properties on this step right here. It's not all just one step. You're going to have to use properties of exponents and distribution. So the power of a power property of exponent says you multiply this exponent times this one. So on this right side is going to be 2 to the 3x minus 3. So the 3x minus 3 is all in the exponent, and here on this side is 2 to the 6x. Okay, so then look at the base of the same, we can set the exponents equal, just like I say here, 6x equals 3x minus 3, and then do whatever steps are necessary to solve. So I'm going to subtract 3x to this side, so that's 3x equals negative 3, divide by 3 on both sides, so in this case x must equal negative 1. Okay, now here is another example, a you try. In this case right here, for example 1, 25 and 125. What's the common base that you can bring both those down to? You can bring both those down to 5. So I want you to pause the video and try to figure that one out. Okay, you should have paused the video and tried to figure that one out. The answer in this case is x equals 2. How did you guys do on that one? Okay, now let's go on to example 2 for this first part of the video. This part, all they want you to do is to rewrite the equation using logs. I kind of went further on that and related this is, why are they doing this? This is kind of weird, but it's leading into example 3. But it kind of is the change the base property. All you really have to do to rewrite using logs is take the log of both sides. So if I take the log of 17 and take the log of 4 to the x, boom. That's how you actually do it. When they write it in the textbook, the power of 10 thing, it's very confusing and ambiguous, and I kind of want you to wipe that out of your memory. So anyway, we can use the power property right here. I bring the x out front, so it's x log 4 over log 17. And remember, the log of a number is just a number that lives in your calculator. So divide both sides by the log of 4. And this is calculator buttons in parentheses right here to solve for x. Now we did the same thing before school let out with the change of base. This is exponential on this side. If I take this and rewrite it in logarithmic form with log base 4, remember when we change the form, we change the sides of the other numbers. So the 17 would go there and the x would go there. But remember, the change of base formula says if you have an odd base, then you can rewrite this piece right here as log of 17 over log of 4. And look, that's exactly what we have over here. Okay, that's the first part of this video. It's part 1A, I guess. Part 1B will be up in just a minute.